Good morning, dear friends. How are you? Today, we will talk about several graphic methods and statistical analysis. Because when in psychology you will go for research or experimentation, you will get the data. And data is always in the two form, qualitative and quantitative. Qualitative means when you are talking about the properties, for example, say he has a good height, he is intelligent, he is superior, he is inferior, he is average, this weight is less, this is more heavy. Now, this is qualitative. And when you put numbers, it is 6 inch, it is 5 feet, this is 2 kg, this is 5 kg, his IQ or her IQ is 110. When you put the number, the data is converted into the form of the quantitative analysis. And when quantitative analysis comes, then we have to use statistical analysis and graphical method to interpret, to analyze the data. In last few lectures, I have presented you, I have taught you, I have told you about frequency polygon, histogram, ogive, percentile, percentile rank. We had already talked about all these points in my previous lectures. Today, we will see that how different, now these graphs will be different from the polygon and the histogram, and then I will come to again polygon and histogram and will try to show that how percentile and other things can be calculated. Now, first we will talk about very simple. So, let us start graphical methods and statistical analysis. Now, the first thing I have shown you figure 1. Now, this is figure 1. Now, if you look at the figure 1, on the OX axis there is a age, age group 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That means age from 18 to 8 to 18. And these are the on the OY axis. In my previous lecture, I have told you that about what is OX and OY axis. Now, on the OY axis, there are number of ideas produced, whether the 8-year child is producing more ideas or the 9-year or the 10-year, and how there is a sex gender difference in producing the ideas. Now, if you look at this graph, now at the age of around 15, you see, look at the age 15, now the graph is shooting up. That means at the age of 15, the ideas production is maximum, and there is a certain decline, and then there is again slightly rising up, because whenever you start any curve, any graph, any curve, first there will be warm up, the progress will be slow, then it will increase. Now, a point comes when there is a neither increment nor decrement, that is called plateau, and then a fatigue comes, and that fatigue reduces the graph or reduces the performance, and when the end comes, the graph again shoots up. So, this graph shows us that the age of 15, there is a producing of ideas are more at the age of 15, and girls are getting more marks, they are producing more ideas in comparison to the boys. Now, this is figure 1. Now, we will explain what is that. Figure 1 shows an age process curve or trend line. This is called trend line. The graph represents changes in logical memory for a connected passage approach found for boys and the girls from age to 18, as I have told you, age 8 to 18, 18 years old. Norms for adults are also included at the extremes of the diagram. Age is represented on the horizontal or OX axis, and mean number of ideas reproduced at each age level is marked off on the vertical Y axis. As I have told you, this is the age and this is the number of ideas. Now, memory ability as measured by this test rises to a peak at the year 15 for both the groups, after which there is a slight decline followed by a rise at the adult level. There is a consistent sex difference, the girls having produced higher idea than the boys over the entire age group. Now, this is what I explained you just now at the age 15. Then as the age grows up 16, 17, 18, as maturity comes, the number of ideas again increases. So, slight decline, look here, and then again it shoots up. So, this graph we can say it shows a trend line, and we can draw this graph when such type of the data emerges before us in the research or the experimentation whatever we do. The second graph illustrates a learning or we can say practice graph. These trend lines show the improvements in sending and receiving telegraphic messages. This is a hypothetical example, telegraphic messages. We can take any problem, it depends on our problem and the data. Resulting from successive trials at the same task over a number of 48 weeks, improvement is measured by a number of letters sent or received and is indicated along the y-axis. Weeks of practice as designated tasks are represented by equal intervals laid off. Now, you see this is the graph. Now, here weeks of practice 4 weeks, 8 weeks, 12 weeks, 16, 18, 20, 24, 28, 32, 36, 40, 44, 48. Now, weeks of practices. Now, on the y axis number of minutes 20, 40, 60, 80, 120. Now, in 20 minutes how many messages you are receiving and you are sending. Now, this graph shows as the practice increases, the message sending is increasing. Again, as I told you that as the work progresses there is a fatigue and there is a decline also. Now, here message receiving, it shoots up, that it is a constant plateau. But I told you neither increment nor decrement is straight line. Clear? Now, after the practice of 28 weeks, it again go up. So, if the data is such, we can represent and we can make the practice graph in this way. Then the third graph we are showing is the shows performance or practice curve. It represents 25 successive trials with a hand dynamometer made by a man and woman. Dynamometer means the pulling or pushing. A marked sex difference in strength of the grip is apparent throughout the practice period. Also, as the experiment progresses, fatigue is noticeable in both the subjects. If you look at this graph, figure number 3. Now, in this this is the trials. First trial, third trial, fifth trial, 7th, 9th, 11th, 13, 15, 17, 19, 21, 23 and 25. Now, this is the grips in kg. Now, how many grips you are making? Grip in dynamometer when you are making the grip. Now, if you look at the data, now this is trend in the male and this is trend in the woman in the female. That means men are doing better than the female, but as because it's a physical task, as there will be fatigue, now graph will come down and it is coming see it is coming down, the again rise, again down, rise, down. So, this graph we can see that how the practice curve we can make when we are doing a different type of the works, any type you want in your experiment or the research. Now, the fourth diagram figure which I am showing you, the graph I am showing you is very famous. I am not saying very famous, and this is known as curve of retention. It is also known by the name forgetting curve, and this was given by Ebbinghaus. You see, is known by the name Ebbinghaus. Ebbinghaus was a German psychologist, and he was working on the memory forgetting, and he did his experiment on his own. You see, there is a big contribution of Ebbinghaus when we talk about the memory or the forgetting. Why big? Why important? When the Ebbinghaus started working, a problem came in his mind that what type of the material I should take. Now, there may be the names Ram, Sham, Ashok, Geeta, Rahman, anything, Rahim, we can take any name. So, he said that if I say Ram, Rahim, Ashok, Geeta, Sita and try to recall, now I am recalling Ram, Rahim, Ashok, Geeta, Sita, I can't say that my memory is 100%. Why? Because these names are already lying in my repertoire. Repertoire means memory storage. Daily we say Ram, Rahim, Ashok, Geeta, Sita. So, these names are already in my memory. So, if after seeing, I recall these names immediately, it does not show my memory. So, a problem came before the Ebbinghaus that he wanted such a material which he could never have seen, nor spoken, nor read. At that time in 1885, Ebbinghaus discovered a material which we are still using in our laboratories when we are trying to learn you or make experiments on the verbal learning, and that material is called nonsense syllabi. So, nonsense syllabi are those words which carry no meaning. Now, you will say, sir, how we can make? He suggested a formula, he gave a formula, and that formula is called CVC. C means consonant, V means vowel, and C means consonant. Consonant, vowel, consonant. You know, in English you have 5 consonants A, E, I, O, U. So, if I make Z, O, P, now Z is a consonant, O is a vowel, and P is again a consonant, so CVC. So, this is the contribution of Ebbinghaus, and this curve which we are talking is based on nonsense syllabi. Now, since I talked about nonsense syllabi, a doubt should not come in your mind. Even we can form nonsense syllabi by the formula CCC. CCC, it does not should carry any meaning. It is not necessary, it is trigram. You can take the 4 letters, 5 letters. Now, when we will come into the learning experiment, learning in verbal learning in some other semesters, then I will talk about the meaningfulness of these and other extra additional points regarding the nonsense syllabi. Because here we are talking about Ebbinghaus curve. So, it was important that we must know that what type of the material he should have taken. Now, figure 4 which I will show is the famous Ebbinghaus curve for retention. It represents memory retention of nonsense labels, because nonsense labels, what are those? I have just explained you. Nonsense labels as measured by the percentage of the original material retained after the passage of different time interval. Time between learning and relearning is shown on OX axis, and percent retained is laid up on the OY axis. If you look at this now, the graph, this is called retention curve or forgetting curve of Ebbinghaus curve. Now, this is the percentage of retention 10, 20, 40, 50, 60, 70, 80, 90, 10 and 100, and it is after 1 hour, 9 hour, 24 hour, 48 hour, 144 hour. Now, if you look at that, means when you make me to learn, I make you to learn a material, and after 1 hour I ask you to recall, repeat. Now, it is almost about 100%. It means now as the time is increasing, the memory is decreasing, it is coming down. Am I right? Now, it came, you know, it is, you see graph is coming down, then it is little bit stable. So, this graph is popular by the name retention curve or Ebbinghaus curve, or you can say curve of retention. So, I think the concept of nonsense syllabi now is very, very clear to you. Now, I have already explained polygon, histogram and bar diagram in my early lectures. Now, when you make these graphs not only helps us to understand the data in a easy form. Look at one look, I will interpret the data. Otherwise, I will have to study the whole table. But in spite of easy interpretation, and other advantage of these graphs is that we can make statistical calculations also. Without formula, simply draw the graph and you will able to calculate the percentile, the median, the percentile rank, or the you can very well calculate all these points are the quartile deviation without using the formulas and the calculation. Now, we will try to see that how these methods are helpful in calculating the different analysis. As we know that the median is the point in frequency distribution below which lie 50% of the measures or scores. Q1 and Q3 marks points in the distribution below which lie respectively 25% and 75% of the measures or the scores. Using the same method by which the median and the quartile were found, researchers may compute points below which 10%, 20%, 40, 80 or any percentage of cases below given value. For example, P10 is the point below which lie 10% of the cases. You see, we have talked about in our early lectures that the measure of central tendency is mean median mode, and the measure variability is quartile Q, for which you have to calculate the Q1 and the Q3, Q, SD and the average deviation. Now, what is median? Median is the point above which 50 and below which 50 cases lie. What is Q1? 25, above which 75, below which 25, Q3 75, clear. Like that, we can calculate any point that is a P10, P20, P30, P40 or P80. Now, for example, let us look how. First I will tell you the formula, then I will show by the graph. Formula to calculate the percentile we have already talked about in the previous lecture also. This is the formula for the percentile. PP is equal to L plus PP minus F upon FP into I. Now, this PP means the percentile. This is a small p, percentage of the distribution wanted. For example, if you want 10th percentile, we will write P10. This small p will carry value 10, P10. You want to calculate P33rd percentile, P33. You want P40, 40th percentile, P40. So, this is the percentile. Now, L, lower limit of the class interval upon which PP lies, where the PP will come, the lower limit of that class interval. Now, Pn part of the n to be, now this is calculated PP by Pn upon 100, part of the n to be counted off in order to reach PP. Now, instead of you can write here Pn upon 100. Capital F, sum of all the frequencies of all the intervals which are less in value than the class interval in which PP lies. Fp, frequency of the class interval where PP lies, and I is the size of the class interval. Now, let us see. For example, we want to calculate P10. Now, here I have to note, it is evident that median is P50, Q1 is P25 and Q3 is 75, which I have just talked about. Suppose this is the data before us, the frequency distribution. Now, these are the frequencies. That means frequency word emerges from where? Frequently. How many times it appears? 140 to 144 frequency is 1. So, this class interval appeared only once. 145 to 149, 145, 146, 147, 148, 149, 3. It means these numbers are 3 times. So, this is the frequency. Now, you are to calculate suppose P10. The very first step will be you will calculate the cumulative frequency. Now, cumulative frequency means you will add up frequency from the lower end 140. Now, this is 1, this is 3, 1 plus 3 4, this is 2, 4 plus 2 6, 6 plus 4 10, 10 plus 4 14, 14 plus 6 20, 20 plus 10 30, 38 plus 8, 38 plus 5 43, 43 plus 4 47, 47 plus 2 49 and 49 plus 1 50. Now, n is 50, it is 50. So, first of all you will calculate the value of the cumulative frequencies. Now, you want to calculate P20 for example. First calculate what is the value of PP, PP upon PP minus F. You see in the formula. Now, you are to calculate this value, this one. Now, this value will be calculated how? Pn upon 100. Now, what is P? You want to calculate 10, clear, upon 100 into this value, if you just raise it up, this value is coming as the 5. Pn upon 100 into I, clear. So, this value is coming 5. Now, you will see that what is the class interval in which the 5 the fifth value cumulative frequency is coming. It is coming in this class interval 1 4. Now, 4 to 6, 5th 6, it is coming 150 to 154. Now, this is the value. Now, lower limit of the class interval in which PP is coming, Pn upon 100 is coming. Now, it is starting from 150. Now, you are to calculate the lower limit. For lower limit, you are to subtract 0.5. I explained in detail how to calculate lower limit and upper limit in my early lectures when I talked about exclusively about the your percentile. Now, the lower limit of the 150 is 149.5. So, this is 149.5. So, Pn upon 100 5. Now, what was capital F? The sum of frequencies of all those class intervals which are less in value than the class interval in which Pn upon 100 is coming. So, Pn upon 100 is coming in this class interval. The class interval which are less in value are 140, 144, 145 to 149. So, sum of these frequencies 4. So, this value is 4. Now, what is 2? The actual frequency of the class interval in which Pn upon 100 is coming. So, Pn upon 100 is coming in 150 to 154. So, frequency is 2, this is 2, I size of a class interval, that is 5. So, put the values 148.9 plus solve it, this value is coming 152. It means that 152 is the score above which 90% cases lie and below which 10% cases lie. So, this is the calculation by the formula. Similarly, you can calculate P20, the value P30, P40, P50. I have already solved all these values before us, so that you may not have any difficulty to understand in calculation of the percentile. So, I have explained you that how to calculate the percentile. One thing should be very clear to you also, that if you calculate the value of median and P50, the value will be the same. Why? Because P50 means above which 50%, below 50%, and what is median? Above 50%, below 50%. So, this was the calculation of percentile by the formula statistical calculation. Similarly, we can calculate the percentile rank statistically by using the formula or the steps. Since I have already explained you to determine percentile rank with the formulas, so without wasting the time, we will come here how to calculate percentile rank on the graph, which that will be it will be type of the revision to you also. So, cumulative frequency graph and the cumulative percentage curve, which is called ogive, we will talk about. The cumulative frequency graph is another way of representing a frequency distribution of a diagram. Before plotting the graph, the scores of the distribution must be added serially or cumulated. Now, whatever the score you are, you just calculate it in a serially or the cumulative manner. Now, this is the problem. 140 to 144 is the lowest and 195 to 199 is the highest score, with the frequency 1, 3, 2, 4, 4, 6, 10, 8, 5, 4, 2, 1. Now, calculate the cumulative frequency. One thing more I want to make it clear, don't confuse by the symbols, because every book writes sometime different symbol. Some people in cumulative frequency write capital F. So, if we are writing capital F, that is also cumulative frequency, or we can also write CUMF, cumulative frequency. The abbreviation, the symbols which I am using is given by Garrett in his book, and that is a very popular book of statistics and very simple. You can very easily understand even when you go through that book. So, do not confuse if somebody says it is a capital F. So, as I told you earlier, we will start from the lowest step 1, 3, 4, 2, 6, 4, 10, like that we will go up to the 50, and is 50, the highest will be 50. This we have already talked about just now. Now, you will calculate upper limit of each class interval. Upper limit means where the score is ending, what will be the upper limit. Now, this is 144 to 144, upper limit is 144.5. If you want to know simple mathematically, add 0.5 in any score, it will be the upper limit, subtract 0.5 from any score, it will be the lower limit. Now, if you want to understand why it is upper limit, so if I write 144.6, mathematically if you convert 144.6, it will become 145. 144.7 will become 145. So, this means 144 can maximally go up to 144.5. So, this is the upper limit of the score. So, this class interval 149, 149.5, 154, 154.5, 159, 159.5, 164, 164.5, like that we have calculated the upper limit of each class interval 169.5, 174.5, 179.5, 184.5, 189.5, 194.5 and 199.5. Now, In plotting the frequency polygon, the frequency on each interval is taken at the midpoint of the class interval, but in constructing a cumulative frequency curve, each cumulative frequency is plotted at the next upper limit of the class interval upon which it falls. This is because in adding progressively from the bottom up, each cumulative frequency carries through to the exact upper limit of the interval. As I told you, the first point on the curve is on y axis, the cumulative frequency on 144 to 144, that means above 144.5, because the upper limit of 144 is 144.5. The second point is 4 y units above 149.5, the third is 6 y unit 154.5, like so on. Now, you see, this is the cumulative frequency graph. Here you have written the cumulative frequencies and here you have written the upper limit of the class intervals. So, plot upper limit frequencies 2, for example 2, like that, make the points and just go on adding. It will become your cumulative frequency graph. Now, the cumulative percentage curve or ogive differs from the cumulative frequency graph in that frequencies are expressed as cumulative percentage on n on the y axis instead of as cumulative frequencies. The conversion of cumulative frequency into cumulative percents can be carried out by dividing each cumulative frequency by n and multiply by 100. For example, if n is 125, the cumulative is equal to 2, then cumulative percentage frequency f will be 2 upon 125 into 100, that is 1.6. Now, this is the data before you. Now, for example, 24.5, 29.5, 30, this is the data and it is 2, 4, 6 and total is 125.9. So, first calculate the rate and then find the percentage. I have told you, just I have explained you. You see, f2 upon n 125 into 100, it will become 1.6. Now, this is we have calculated 1.6 for the second 4.8, 21.6, then 21.6, 37, like that you will calculate the percentage frequencies. After that, now you will make the graph. Exact interval limit is laid on the x axis consisting of 10 equal distances, each representing 10% of the distribution is marked off on the y axis. Now, this is actually called, this graph is called the ogive. Now, you see, this is the graph now. Look, 24.5, 29.5, 34.5. Now, what is 24.5? Go back the data, go back to the data. This is 24.5 upper limit. So, we have already given here the upper limit. So, 24.5, 29.5 upper limits. Now, these are the cumulative frequencies which we have calculated by the rate. Now, 24.5, what this is the basic, what is value? Just put on 29.5, this point, add it up. Now, this graph you will get, which we have already explained in our previous lecture. Now, you are to calculate the percentile. Now, for example, you are to calculate P50 median. So, draw a line and draw the perpendicular. Now, where it will touch on the baseline, this value will be the value of P50. You want to calculate P9, for example, 75, 70 and 80, this is 70, calculate, it will come down. So, without calculation, without using the formula, we can calculate the value of the percentile. Similarly, we can calculate the percentile rank without steps. For example, I want to calculate the percentile rank of the person who is getting 59.5 marks. So, this line goes up, it will go up 59.5, this will go here, it is 100. That means, those who is getting 69.5, he is getting the highest percentile, that is 100, there is a no score beyond that. If you want to calculate the percentile of the 44.5, go here, it will come, it is 25. So, with these graphs, we can make the statistical calculation. So, graphs are useful not only to understanding and interpreting the data, but also in making the statistical calculation. So, this was all about the graphs and their interpretation and statistical analysis. This is all for today's lecture. Thank you very much.